This is the solution for section 8.2, problem number 16. All right, so it says use a definite integral to derive a formula for the volume of a right circular cone of altitude h and radius r. All right, so you're given the graph here where we see the x and y axis, and then we see this line here that goes from 0h to r comma 0. So if we take this and we revolve it around the y-axis, right, what is that going to give us? Well, that's going to give us a right circular cone, right, where this is going to be revolved and we're going to end up with a cone. All right, and so how do you find the volume of a cone? Well, this is what we're going to do here. All right, so first of all, I need to think about if I'm revolving around the y-axis. All right, I'm going to be using a dx. Sorry, not a dx, a dy, right? Because a dy is perpendicular to the axis of rotation, and that would allow me to use the disk method. This is actually a disk method, not a washer method, right? Because there's no gap between the region and the axis of rotation. All right, so first, though, I actually need to come up with an equation here. So what is this equation? Well, it has a slope of what? Well, if you think about it, the slope here would be the rise over the run. So you're starting at 0h, right? And you're going to r0. So the slope would be the h minus the 0, right? So that's y2 minus y1 over x2, 0 minus r, right? And so this is just going to be negative h over r. So that's the slope. All right, so our equation is going to be y equals slope negative h over r times x, so mx plus b. So what is b? The y-intercept, that would be h. All right, so that equation is y equals negative h over r times x plus h. All right, now what we want to realize, though, is if we're using a dy, we actually want this not in y equals form, we want it in x equals form. So I have to solve for x. So first thing that I'm going to do in order to solve for x is I'm going to multiply. You could multiply by r, right, and then subtract and then divide by h or whatever. So I'm going to subtract h, so I have y minus h equals negative h over r times x, and then I'm going to divide by negative h over r. All right, so if I divide by negative h over r, we get that x is going to be what? Well, x is going to be y minus h over negative h over r. So instead of dividing by negative h over r, I'm going to multiply by negative r over h times y minus h. And so if I simplify there, I get x equals negative r over h times y plus, and what happens here if I multiply this, the h is reduced and it becomes just r, right? So that is our x equals equation. All right, so now, how do I find the volume of this cone created by revolving that region around the y-axis? All right, so the volume is going to be found by taking, once again, pi times the integral of parentheses squared with respect to y. All right, so what are in the parentheses? Well, tilt your head to the side. What is the right-hand boundary of the dy? It is negative r over hy plus r minus the left-hand boundary, which is 0, so minus 0. Now, we're integrating from the lowest y value, which is 0, to the highest y value, which is h. All right? So now, it's important that you remember that in this integral, y is the variable. R and h are unspecified constants. All right? So now let's carry this integral out. So I have pi times. Now, in order to do that, I'm going to have to multiply it out. So I have integral from 0 to h. All right, so when I multiply this out, I get negative r over hy times itself. So that gives me positive r squared over h squared y squared. All right? Then I have the negative r over hy times the r and 2 of those. So I have minus 2. If I multiply this, I get r squared over h times y. And then I multiply this by itself, so I get plus r squared. So we're going to integrate all of that with respect to y. So remember, the key is with respect to y. All right, so pi times integral from 0 to h. All right, so now, if I have r squared over h squared, that is just a constant, right? So r squared over h squared, y squared. All right, so now let's integrate y squared. That would be y cubed over 3. All right, minus, now, the 2r squared over h, that is a constant, times the integral of y, which is y squared over 2, and then plus the integral of r squared. Remember, that's not r cubed over 3. We're integrating with respect to y. It's r squared times y. And we're going to evaluate that from 0 to h. All right, so now, very important that you remember, we are plugging h in for y. All right. So what do I have? I have pi times. All right, so r squared over h squared, and y is h cubed over 3 minus the 2's we could reduce there. So I have r squared over h times y, which is h squared, plus r squared times h. Right? That's the first part. And then minus. Now we're going to plug in 0 for y. So the whole thing is just going to end up being 0. So we can just kind of put 0 there. All right. So now we just want to simplify. All right. So the first term. All right. I've got r squared, and then I've got an h cubed and an h. So the 2 of the h's reduce. So I get what? R squared h over 3. Right? Minus. All right. This one. H squared and h, so those reduce. So I'm just left with minus r squared h plus r squared h, and so those actually subtract out. And so I am left with pi times r squared h over 3, or the volume formula that we probably know is 1/3 pi r squared h. And so that is where the volume formula for a cone comes from.